The MEG Motionless Electricity Generator. Tom Bearden, Stephen Patrick, James Hayes, Kenneth Moore and James Kenny were granted U.S. Patent 6,362,718 on March 26, 2002. This patent is for an electromagnetic generator with no moving parts. This device is said be self-powered and is described and illustrated on J.L. Naughton's website at http://jnaudin.free.fr/meg21.htm, where test results are shown. While this device has been claimed to have a greater output than its input and an output 5 times higher than the input has been mentioned, I am not aware of anyone who has attempted to replicate this device and achieved a coefficient of performance greater than 1 performance, and so, for that reason, it is described in this section describing devices which are unlikely to be worthwhile for the home constructor to attempt to replicate. The motionless electromagnetic generator or MEG consists of a magnetic ring with output coils wound on it. Inside the ring is a permanent magnet to provide a steady magnetic flux around the ring. Superimposed on the ring are 2 electromagnets which are activated one after the other to make the magnetic flux oscillate. This is very much like Floyd Sweet's VTA device. Sensing, switching and control circuitry. Oscillator coil. Permanent magnet. Magnetic yoke. Pickup coils. Degree rectifier and regulator. Any load. The external power source shown above is intended to be disconnected when the circuit starts operating, at which time, part of the output from one of the pickup coils is fed back to power the circuit driving the oscillator coils. The circuit then becomes self-sustaining, with no external input but with a continuous electrical output. If you should construct one of these, please be warned that it should not be started up unless there is an external load across the pickup coils, otherwise dangerous, potentially lethal voltages can be produced. Don't get yourself killed or injured. Please be very careful. A reworded excerpt from the patent for this system is in the appendix and it gives the construction details of the prototype, dimensions, number of turns, materials used, drive frequency, monostable pulse durations, etc. The prototype produced 2 outputs of 48 watts for 1 input of 12 watts. This allowed the input power to be taken from one of the outputs, while that same output was powering other loads. This device is essentially a custom-built transformer with 2 primary windings, the oscillator coils, and 2 secondary windings, the pickup coils, with a permanent magnet inserted to create a standing magnetic field through the yoke, frame, of the transformer. However, a permanent magnet has 2 separate energy streams coming from it. The main field is the magnetic field, which is very well known. It normally flows out in every direction, but in the MEG, a very good conducting path is provided by the frame of the device. This traps the magnetic energy flow and channels it around inside the frame. This prevents it masking the second energy field, which is the electrical energy field. With the magnetic field moved out of the way, it is now possible to tap this energy field for additional power output. The MEG looks like a very simple device, but in actual fact, it is not. To act as a successful device with a coefficient of performance, COP, over 1, where the input power which is provided is less than the useful power output of the device, then Tom says that the frame needs to be made from a nanocrystalline material. This material has special properties which give the MEG its exceptional output. Care has to be taken with this device as the output power can be so high that it can burn the insulation off the wires and destroy the device if the output power is not controlled carefully. The output power is normally limited to a coefficient of performance of 5.4 for practical reasons. If the necessary input power is taken from the output power via a rigorous control circuit which prevents runaway, then the device can provide output power while no outside input power is needed. The output power is controlled by the waveform being sent to the oscillator coils. The power is controlled by the exact shape of the square wave drive. Sharp rise and fall, high output power. Less sharp rise and fall, lower output power. This waveform is adjusted carefully to keep the coefficient of performance down to 5.4 for safety's sake. The waveform is also adjustable for frequency and mark space ratio. As it is some years since this device was patented, the question can be asked as to why it is not in production and offered for sale everywhere. The reason is that the MEG is a laboratory prototype which needs careful adjustment and tweaking. It has been replicated by others and its performance verified as being coefficient of performance greater than 1, but it is not yet ready for production where it is necessary to have the design enhanced to the stage that it can be assembled in a factory and work immediately without the need for manual adjustments. That development is in hand and may be completed in the next year or two. Some further explanation is in order. The MEG has an overall efficiency, well below 100% in spite of having a coefficient of performance well in excess of 1. The coefficient of performance of 5.4 mentioned earlier is an arbitrary figure selected by the designers to prevent the insulation being burnt off the output wires. The actual maximum output is almost unlimited. Certainly a coefficient of performance of 100 is perfectly possible, but quite unnecessary in practical terms. If a standard laminated iron yoke is used for the MEG, it will never have a coefficient of performance greater than 1 as input power will be needed to make it operate. The magnetic flux from a permanent magnet consists of two components. One component is rotary and it spreads out in every direction. The second component is linear and it gets swamped and hidden by the rotary field. If a toroidal yoke wound with an input winding over its whole length is used, then that traps all of the rotating magnetic field inside the toroid. The snag is that this requires considerable input power to energize the toroidal winding. The big advance with the MEG is that the inventors have discovered some standard off-the-shelf nanocrystalline materials which have the property of trapping the rotational magnetic field inside a toroid formed from them, without the need for any energizing coil. This is a major boost to the functioning of the device. Now, with the rotational magnetic field trapped inside the toroid, the liner field becomes accessible, and it is a very useful field indeed. It is electrical in nature. In actual fact, magnetism and electricity are not two separate things, but instead, they are different aspects of the same thing, so both should really be referred to as electromagnetism. Anyway, the linear field is easy to access once the rotational field has been removed. All that is necessary is to pulse it sharply. When that is done, real electricity is introduced into the MEG from the surrounding environment. The sharper the waveform, the greater the additional electrical input becomes. This is what makes the MEG have a coefficient of performance of say, 5.4, which is a practical working output. If the output is then manipulated to provide the input power needed for the pulsing, the coefficient of performance effectively becomes infinite as you do not have to provide any power to make it work and you have a substantial power output. The power output divided by the power input you have to provide to make the device operate, gives the coefficient of performance rating, so any output divided by zero input, always gives infinity. Dave Lawton has experimented with the MEG arrangement, using a professionally constructed custom laminated iron yoke. He found that using the standard arrangement, he found no difference when he removed the permanent magnet. Testing various configurations, he found that the most effective setup for his components is silicon iron C-shaped core, laminated bridging iron, control coil, permanent magnet, output coil, control coil, output coil. Bridging iron laminated 3 times 0.5 times 0.5. Here, the drive coils are both put asymmetrically on one side of the frame and wired so that their pulses complement each other. Then 2 pairs of button magnets are placed on the other side of the centerline, each side of the yoke, and bridged together with 2 straight vertical sections of laminated iron bar. This arrangement is sensitive to the exact position of these magnets, and tuning is achieved by moving the group of 4 magnets and 2 bars, effectively 2 horseshoe magnets, slightly left or right to find the optimum position. Introducing or removing these magnets then made a considerable difference to the operation of the device. While most people find it very difficult to get coefficient of performance greater than 1 operation from the MEG, I am reliably informed that WITs have succeeded in producing self-powered replications. There is, on the web, an exceptionally well-written presentation by Jacco van der Werp entitled The Hitchhiker's Guide to the Free Energy MEG at http://youusa.com Citic 2002 Citic, 2002, 0601 SHTML, and it explains how and why it can work. By kind permission, it is reproduced here. A Hitchhiker's Guide to the Free Energy MEG. youusa.com, 25, June, 02. Jacco van der Werp. Forward by Marshall Masters. This article by Jacco van der Werp, a Dutch physicist, explains the free energy magnetic energy generator MEG simply, in layman's terms. I worked closely with Jacco on this project and sent a polite request to Lee Kenny, one of the MEG principals, for assistance. His quick response was controlling and reeked of paranoia. You are not authorized by MEL to publish any information regarding the MEG. Readers can view and comment on the full text via the YOWUSA message board post, MEG, Masters and Kenny. At first, his paranoid reply puzzled me, but as we further investigated the MEG we came to understand the paranoia and it chilled our blood. Perhaps this particular genie should be left in the bottle. My first reaction to Kenny's suppressive controlling behavior was to shoot back a reply reminding him that there is a funny little piece of paper called the Constitution. After that, the urgent paranoia in Kenny's response continued to task me. An obvious and simplistic explanation is that Bearden are busy subscribing to Yachting magazine and setting up bank accounts in offshore tax havens for their new-to-be wealth. The problem is that is too simplistic an explanation, because after working with engineers for 25 years I've learned to recognize a knee-jerk paranoid reaction when I see one. Kenny's reply was quintessential a knee-jerk paranoid reaction. Perhaps, I would have reached this conclusion early on, were I not so enamored with the MEG technology. But as dug deeper, I found more tangible reasons for Kenny's paranoia. The process of invention is a passionate one. At the end of the process are the hopeful financial rewards, but for something as complex as the MEG there is an equally large reward, peer recognition. Damn your eyes, but you did it. In this heat of invention the post-reality dimensions are discussed but at a lower level and with less emphasis. I believe this is what may have happened to the MEG inventors. They simply got so carried away with the passion of invention that it clouded their view beyond the moment they would receive their patent, which in turn would embrace their paradigm-shifting theories with plausibility. However, once the patent was issued, the types of articles one would expect to see in magazines like Popular Science and Popular Mechanics failed to materialize. Further, what was made available by Bearden was such geeky technobabble that it usually sails over the head of the average man. I now believe there was a reason for this. The MEG opens a doorway into a new future, filled with new applications that will build upon the fundamental concepts of the MEG. Like the nuclear genie America unleashed upon Japan, the MEG genie offers us both a new and better world as well as a dead world all in the same breath. I believe this explains Kenny's paranoia. Now that he and his fellow MEG-MEL partners are looking at the practical applications of their invention, they are starting to see it from outside the box, as they say in the computer business. So what could they be seeing that makes them want to control the flow of knowledge about this new invention? While the focus now is on the free energy application of MEG technology, its ability to interact and deform the space-time continuum offers an alarming new range of applications to include, weapon of mass destruction, interstellar space drive and time machine engine. And that is only the beginning of the hypothetical possibilities that could emerge from this paradigm-shifting invention. However, before this genie is let out of the bottle, our elected representatives and all of us in the mainstream need to understand the MEG a little better. That is the goal of this superb article by Jacco van der Werp. A Hitchhiker's Guide to the Free Energy MEG. This fourth article in a YOWUSA series on the motionless electromagnetic generator by Tom Bearden, now under patent, discusses this groundbreaking technology in non-technical layman's terms as opposed to delving deeply into the physical principles behind the MEG. Once you have finished reading the article, you will have a general idea of how the MEG works and why its inventors call it a free energy machine. For those with bolder interests in the precise formulas and equations describing the MEG, those working on the project have already published several technical articles on the internet. The best of these is a 69-page PDF file called the Motionless Electromagnetic Generator, extracting energy from a permanent magnet with energy replenishing from the active vacuum. This document lays out the most basic principles used for the MEG with some graphics added in. Getting to know the MEG. The MEG represents a revolutionary approach to generating energy in our ever more demanding economy. However, it may also become a huge financial threat to big energy companies, as Marshall Masters outlined in his article Bearden's Free Energy MEG Destined for Chapter 11. However, if the MEG grows into its destined role, it will conquer the market. It will do so by providing mankind with a durable and above all clean source of energy, which so far no other source of energy has achieved at an affordable price. For the common person, the MEG is an obtuse technical wonder, and understanding why it works requires one to dive headfirst into what seems to be a bottomless pool of technobabble. However, if we pare the issue down to 5 basic technological terms, we can create a basic understanding of the MEG. In a MEG device there are 5 basic terms playing an important role in making it work. They are energy, flux, efficiency, capacitance, magnetic field and shielding. This article will attempt to explain each MEG term simply, using everyday examples. After the basic explanation, we will explore a full analogy in the form of a rain barrel. Flux. Flux, or energy flux to be more precise, is essentially a byproduct of energy creation. For example, an automobile engine uses a mixture of gasoline and air to power the car. Older engines in particular were not extremely efficient in burning all of this mixture, and the byproduct is the smog that comes out the tailpipe of the car. Modern car engines are more economical, less unburned gasoline goes out their tailpipes. However, even the most efficient cars on the road today still push unburned gasoline out the tailpipe. On top of that, part of the heat generated by the burning of the gasoline inside the engine also leaves that way. In a manner of speaking, the smog that comes out of your car's exhaust is like flux. It is a byproduct of the process of creating the energy needed to make your car travel down the road. Flux and efficiency. Before the oil embargo of 1973, American car designers largely ignored the issue of flux by building cars with larger engines to go faster. Consequently, this fuel economy suffered from the embargo. However, in 1973 the price of fuel did not make this an important issue. Once the fuel price rose after 1973, American auto manufacturers began losing sales to foreign manufacturers who were building more fuel-efficient engines. Efficiency. We define efficiency as the useful application of energy flow. This means that if we build a more fuel-efficient engine, it will send less unburned fuel out the tailpipe and thereby increase the number of miles we can go on the same amount of gasoline. The part we call useful here is the energy of the burned gasoline whose heat is used to move our car. That is what we aimed for, that part divided by the total energy that could be produced from the amount of gas we used, is called efficiency. Efficiency and unity. Since 1973, the goal of auto manufacturers is to use the available energy in gasoline as much as possible. The most they can hope for is what is called unity. Unity means that a system can use 100% of the energy input into it. In this case, that would be the energy stored in the gasoline to generate the desired output. The output in this case is the horsepower our engine delivers to move our car down the road. No matter how efficient the designs are in pushing toward unity, the most a system can hope to achieve with present technologies is around 30% efficiency, which is some 70% short of unity. Unity and closed systems. When we commonly think of unity, 100% efficiency, we also tend to think in terms of closed systems. A closed system is a system that is completely isolated from the rest of the world. In a manner of speaking, an automobile engine is a closed system. The energy released from the burning of the gasoline to extract its energy is either captured to power the car or blown out the tailpipe as wasted flux. Likewise, you continually reduce the amount of gasoline in your tank as you drive down the road. The total amount of energy that is either still stored in unburned gasoline or is moving your car along or is leaving the tailpipe as waste flux is constant. The essential point to keep in mind about a closed system is that it does not draw energy from the environment around it. On the other hand, an open system does draw energy from its surroundings. Closed systems and open systems. If we were to create automobiles with open systems, what would they look like? They would have the same engine, but an automobile with an open system would, for example, have a mast and a sail. In this case, the driver would use the automobile engine to raise and lower the sail. The raised sail completes an open system by capturing motion energy from the wind and using it to propel the car down the road, provided the wind is with you. Once you have raised the sail, you can make the car go forward by angling the sail to the wind. To slow, you can position the sail in line with the direction of the wind, thereby neutralizing it as an active, open power system. Once you raise the sail, you do not need the car's engine for propulsion. The essential point to keep in mind about an open system is that it draws energy from the environment around it, like the sail on our modified car. In addition, it is controllable in that you can turn it on and off, just like a closed system. Open systems and the coefficient of performance, COP. Because the auto sail is not limited to the energy of the fuel in the gas tank, which can never exceed unity or 100% efficiency, an open system, portrayed here by the auto sail, can in fact exceed unity. In other words, it can obtain more than 100% efficiency from the energy system it is interacting with, which in this case is the wind. So how do we measure systems that can achieve more than unity? The term coefficient of performance, COP, compares the amount of energy input into a system versus the usable amount of energy output by the same system. For example, if using the engine in our auto to raise the sail requires 1 unit of energy, and that when the sail is raised it generates or gathers 8 units of wind motion energy, the coefficient of performance is 800%. Another way of expressing this is 8, 1, where 8 is the useful energy available and 1 is the amount of energy inserted into the system to trigger the generation of usable energy. Coefficient of performance and capacitance. In our car example, we used a sail to propel our car to achieve an 8, 1 COP. Could this work with larger systems? For example, could it work with trucks as well? We already know that sails were used to propel huge wooden sailing ships centuries ago. Let's go back in time to sailing ships for a moment. The builders of these great ships knew that the more and bigger sails they added to their ships, the faster they would go. However, great expanses of water surround that ship on the ocean. With this in mind, let's see how this applies to using sail power to propel cars and trucks. Because cars and trucks travel in close proximity to each other and in the same direction on a highway, the amount of wind energy available in the open system must be divided amongst the various vehicles. Consequently, those in closest proximity to the wind direction will bleed off wind power from those ahead of them. In essence, they literally steal each other's wind. In terms of capacitance, the essential concept here is that open systems may not be unlimited systems. In the case of our auto and truck sails, the proximity and number of sails accessing the same open wind system for energy will drain the open system. In other words, even if an open system is free, capacitance tells us that there is only so much of it to go around. At this point, we've discussed some general terms used with the MEG. Now we're ready to discuss terms that are more specific to the MEG, beginning with fields. Fields. In very simple terms, a field is any mechanism that serves as a means to an end. In the car example, we used a sail as our field, in that it gathered energy from the open wind system. Unlike the sails we use as fields to capture the energy we need to propel our cars, in terms of the MEG, we must use something called a magnetic field. Magnetic fields. In the case of the auto sail, we used our sail as a field to pull energy from the open wind system around us so that we can propel out autos. The energy we needed was stored inside the wind. With the MEG, The energy source we need to tap is not the wind, but electromagnetic forces of the universe that are just as omnipresent as the wind is on Earth, if not more so. What the sail and the MEG have in common concerning the fields is that they must control their fields in order to prevent undesirable side effects. Looking at our auto sail example, we attach lines to the sail and boom to control the trim of the sail so that it captures as much energy as possible without the sail and causing damage. Hence the popular sailing term, trimming the sails. Likewise, untrimmed sails can be dangerous, presenting a hazard to systems such as the boom and mast, or to the sailor if the wind moves the sail and boom violently across the ship, upsetting the balance of the ship. In a manner of speaking, the MEG uses something called shielding to achieve the same thing as controlling the trimming of the sail, if you will. Without it, violent effects may damage its surroundings. Magnetic fields and magnetic shielding. With the MEG, the magnetic fields are very powerful and must be controlled tightly at all times in order to prevent them from creating havoc in the space around them. This is why the MEG needs to use magnetic shielding. The most important concept of magnetic shielding is that it serves as a safety control for magnetic fields by containing and minimizing their negative effects. The rain barrel example. At this point, we've covered all the bases with the exception of the magnetic vector potential, which forms the crux of the MEG theory. To help you to understand the complexity of this concept, let's first review what we have covered up this point within the context of a simple rain barrel system. The reason for this is that one may understand the MEG magnetic vector potential more easily from a systemic viewpoint. Flux. Some of us may have tried the following as kids or even later in life. If we take a barrel filled with water, or a gas tank filled with petrol, and we want to take some of that out, we do not have to suck it all out ourselves. We take a piece of hose, simple garden hose will do, and stick it into the reservoir from which we want to take the liquid. On the outside, we lower one end of the hose a little lower than the opposite end sitting inside the tank. Then we gently suck on the hose. Let's keep to water from here if only for the sake of taste, and the fluid will start to flow. Once it does, it will continue to flow until the other end of the hose inside the tank is no longer submerged. Therefore, with only a little effort we move a lot of fluid out. The mechanism that makes this work is called the capillary effect. In other words, the weight of the column of fluid in the hose with a height equal to the difference in height of the two ends of the hose is providing the force that is needed to keep the fluid moving. However, what we do know is that the water barrel will run empty if we just pour it all out. On the other hand, the MEG draws energy from a barrel that fills itself right back up. So it never runs empty. If you repeat the stimulated energy flow out of the MEG, energy flux will come out of it continually, it will not run dry like our rain barrel. Therefore, a proper way to describe the MEG therefore in terms of this example would be a rain barrel into which more rain would fall the instant that one draws water from it. Once you start the water flowing through the hose, the rain starts falling into the barrel and replaces the water you're pulling out at a similar pace. For this reason, a MEG-style water barrel will never run empty and the water will flow forever out through the hose once you have brought it in motion because the MEG is an open system, which brings us to the next point of consideration, what efficiency versus COP means for our rain barrel. Efficiency and the coefficient of performance. For the purpose of our rain barrel example, the term efficiency can be defined by the amount of water we can pull from the barrel by drawing it into motion with the siphon hose. With the closed system water barrel, we learned that a closed system is isolated from the rest of the world, so no rain comes falling in from above to replace what we're taking out. In this case the best we can do is position the hose at the very bottom of the barrel on the inside and while letting it hand even LER on the outside. By doing this, we can siphon all of the water out of the barrel, which gives us maximum of 100% of the water. This 100% of efficiency is called unity. Limit. Keeping the unity of our closed rain barrel system in mind, let's shift back to our open system variant. The moment we begin to siphon water from the open system rain barrel, fresh rainwater falls in through the open top of the barrel. No matter how much water we siphon from our open system water barrel, enough new rain falls through the top to replace what we are taking about. Therefore, put in motion a never-ending stream of water with our open system rain barrel, we can obtain results greater than that of unity. This is what the coefficient of performance, COP, is about. We use it to express the output result, which is greater than what we put in. Ergo, the COP for the open system rain barrel can exceed unity, 100% efficiency, whereas the closed system rain barrel can only hope to achieve unity. So then, what happens if we increase the size of our rain barrel? Capacitance. Aside from the direct effect of having more water by increasing the size of our water barrel and siphon hose, there are indirect effects as well, and they need to be carefully considered. For starters, if we make our barrel bigger as well as our siphon hose, what will that mean for us? Given that we'll be using a bigger hose to siphon out more fluid, we'll need a stronger suction force to begin with. We can do that simply, provided we have the lung power, without requiring a scaling up of the entire system. However, if we drain more water per second from a bigger barrel, for example the size of a lake, and we want it to keep running, it will have to rain harder to replenish the water that we take out, and rainfall is bound to a natural at a certain barrel and hose size. Not even a tropical storm will provide enough rain to keep the water level up, and the system will start to collapse. On top of that, a normal barrel stands on a support structure. The bigger the barrel, the harder it will be to find a place for it to stand and remain standing. Otherwise it might fall over or break. So, how do we keep our bigger barrel from coming apart? Fields and shielding. If the barrel gets really big, let's assume for a moment it is the size of Lake Superior, and we start siphoning water out of it at the pace of 4 times the total water flux of the salt-sweet Marie canals, then the water level will take time to readjust for the water poured out. The most important field in action here is the siphoning process, powered by gravity, which results in the water flow out of our bigger barrel lake. Yes folks, now we're talking at a planetary scale. Normally, water level is horizontal, allowing of course for the curvature of Earth on a larger scale. However, if the pace of siphoning gets high enough, the normal water flow will become incapable of correcting the level quickly enough. A permanent difference in height of the water level from one side of the lake to the other will arise. In that case, stopping the siphoning action will not result in an immediate stop in water flowing towards the siphoning point. A sudden stop in pouring from a lake-sized barrel will cause at least a small tidal wave. The bigger the level difference across the lake, the worse the tidal wave will turn out. Although that looks like another field in action in the big barrel system, it isn't. It is a self-correcting mechanism for the lake surface after it has been disturbed. In simplistic terms, what this all boils down to is that the flow energy, like the flow water through our water barrel system, represents a field. As a field increases in size, it can likewise destabilize in greater amounts as well. Therefore, if we wish to increase the size of our fields, we must find ways to shield them from those things, which could destabilize them. Fields and shielding. If our normal-sized rain barrel overfilled with water, it could start to leak. In such a case, we would need measures to prevent a gushing flow of rainwater from damaging the immediate surroundings in a flood. On the other hand, with our lake-sized version of water barrel, we would need dikes to surround our lake to keep it from overflowing onto the land around it. This flooding finds its cause in a pace difference between the raining in and pouring out of the water. These dikes must of course be able to withstand small tidal waves that emerge due to the starting and stopping of the siphoning action. In very simple terms, this is called shielding. Up to this point, we've covered the most essential concepts we'll need before we tackle the big one, vector potential. This is an important yet complex concept, but it goes to the very heart of what a MEG is, why it can do what it does. MEG components and layout. The picture below, taken from the abstract by Magnetic Energy Limited as it published on the internet. We've added the colored placeholders to make it easier to view. This illustration shows the basic layout of a lab prototype of the MEG used to successfully demonstrate the theory. Permanent magnet, A, the most important element is the permanent magnet sitting in the middle of the schematic picture. The magnetic field lines come out of that bar magnet at the top and bottom side, in this picture. This magnet is what helps drive the entire machine. Nanocrystalline flux path and core material, B. Instead of freely circling from the north pole of the magnet to the south pole, they enter a nanocrystalline flux path and core material. That material captures all of the magnetic field of the permanent magnet, so that no magnetic field is present free in the air anymore. Collector coil, C. The collector coils are the points where energy can be tapped from the MEG. Actuator, input, coil, D. The actuators are the points of input of energy to put the much larger amount into motion. To compare it to the rain barrel, the actuators are your mouth drawing water through the hose. The collectors are the hose ends hanging out of the barrel that starts to pour once you've generated a capillary with your siphon hose. And finally, the magnet and the coil containing the magnetic field are the barrel reservoir containing the water. How the MEG works. Now we come to the crux of the whole system, the reason why it works in the first place. The driving force in our large, lake-sized rain barrel was the force of gravity. That made the water that falls at some distance away from our hose move towards the initial siphon point and in turn caused the water to run through the siphon. In this case, gravity is the restoring force of the water level of our lake-sized rain barrel as it makes the water level go horizontal again. This force and the correction mechanism attached to it have an equivalent in the magnetic arena. That force is the magnetic vector potential. If we look at the MEG, we see that it converts an energy flux that was stored in such a vector potential outside a closed magnetic field path. Whoa, wasn't that a mouthful? Let's break it down into more simpler terms. Okay, so what is a vector potential anyway? To explain vector potential, we need to use something other than a rain barrel, but it must be familiar, so why not the energy we use in our homes to run our computers, hair dryers, etc. We all know about the electrical potential across the two wires of a wall outlet. This electrical potential is what makes a light bulb burn. If we're not careful with the outlet, we could also find ourselves flat on our back as our family members frantically call for an ambulance. Thankfully though, the electrical potential is 110 volts, which was chosen because it is not as lethal as the 220 to 240 volts standard found in most of the other countries in the world. However, if we combine the numerical value of this electrical potential with a direction, we have a vector potential. In the case of our 110-volt outlet, if we change the direction from say the horizontal to the vertical, we can double our potential to 220 volts. Therefore, direction is important for the creation of any magnetic field. They all emerge from a magnetic vector potential where direction plays a critical role. The following illustration compares the MEG with our rain barrel example for a very general layman's understanding of how the MEG works and why the magnetic vector potential is so important. Please keep in mind a precise explanation would require an article several times the size of this one, so we'll just paint our picture with broad liberal brush strokes for now. A. An outside reservoir waits until the system is brought into motion and then starts to work to restore the balance that is broken by sucking the siphon hose. For the rain barrel it is the rain filling the barrel back up, for the MEG it is the vector potential converting its energy into magnetic field inside the closed path. B. This adds an extra field to the magnet field inside the closed loop. C. In essence, the actuators work like the siphon hose in our rain barrel example, and by changing the direction of the water it creates an outside vector potential. D. Consequently, the closed path starts to interact with the magnetic field inside, to compensate for the change in the situation. It gives energy to the magnetic field inside the closed path. E. We can then tap that energy from the collectors and we find that more electrical energy comes out the collectors than the amount we put in through the actuators. So energy from the vector potential field outside the closed path is flowing towards the siphon to correct the field level again. If we lead part of this energy back into the actuators again, the rest of it is free flux. Free flux? With the MEG, energy flux actually becomes the result product or output instead of a waste byproduct, as with fossil fuel powered systems like car engines. What used to be waste is now useful output, just like today's electricity drawn from the net to light our houses. In that respect, the MEG forms a new way of looking at energy flux, and if you happen to install a MEG next to your home, it will require far less energy to provide you with far more electricity. Consequently, your energy costs will come down considerably. Why the MEG is commonly misunderstood. The MEG uses an input energy flux to convert a far greater amount of thus far unusable energy flux into a controllable and more convenient form. This can leave some folks scratching their heads because this is a whole new twist on flux. For those who are familiar with the principles of conservation of energy, this represents a paradigm shift in thinking that can defy years of heavily instructed thought about closed systems. And here is the rub. The rigid principles of conservation of energy apply only to closed systems such as automobile engines, whereas the MEG is an open system. Because the MEG is an open system, it can turn flux into output because it is a system out of balance with the world around it and therefore constantly interacting with the environment around it. This way, it may result in a COP that is far greater than unity. Another factor that makes it difficult for conventional thinkers to understand the MEG is that it does not use the Lorentz gauge. When Tom Bearden and his team of researchers discovered the principles behind the MEG when they chose to omit a commonly known calibration of an electromagnetic system, the so-called Lorentz gauge. The Lorentz gauge is essentially a free choice of values for given parameters of an electrical system. This free choice makes mathematics simpler. At the same time, however, it discards a range of interesting, as it turns out now, solutions to a set of equations describing the same system. This range is the range of non-equilibrium states. By keeping the MEG just off equilibrium, out of balance, all the time, we can use it to pull a tremendous amount of energy out of a so far unusable reservoir into a convenient form. In essence, this is what the MEG is about. Potential problems with the MEG. We know that the MEG works, but it is also of interest to see just how much it can do. Most of you will likely be interested to know if a MEG can power a home. Can we scale it up without a limit, or could one such device even power a city? The scale of many devices is only limited by practical design questions. The MEG needs a permanent magnet as well as a nanocrystalline material completely confining the magnetic field loops that leave this magnet. It also needs input and output coils. Electrical currents running through wires will produce heat, which will have to be dealt with at a high enough pace, but other than that, the potential size and productivity of the system is virtually unlimited. This type of generator should a priori be scalable to city block level. There are, however, possible side effects to its operation, which we want to take a closer look at before starting to operate a MEG for a city. A few problems might exist for the MEG. Right now, it is uncharted territory, but we need to consider the possibility that above a certain level, the vector potential field cannot rearrange its energy fast enough for the working conditions to remain intact, thereby causing the MEG to fail. To fully illustrate this possibility, let's revisit some of the basic terms we discussed earlier in this article. Magnetic fields. The energy stored in the magnetic field and the vector potential field may interact with conducting materials outside the MEG as well, generating secondary magnetic fields and electric currents. There's more. As energy leaves its surroundings, new energy comes flowing back in. We do not know if the pace of that is bound to a limit. It may have side effects that are currently unknown to us. Some pessimistic reactions have even spoken of an alteration of the space-time continuum surrounding the MEG. That would be a serious consequence indeed, but we have seen no proof of it so far. Besides the argument presented above, there is the coil material that is supposed to fully contain the permanent magnet's field and the additional field generated during interaction. A bigger MEG will also need a stronger magnetic field. Just how much can the coil material take before the field starts to break up the material itself? This bigger MEG may need superconducting materials to gain that stronger magnetic field. there will be additional conditions that are imposed by that material. We need to maintain that superconductivity to prevent damage to the material. However, stronger magnetic fields do pose a health risk. For this reason, most people do not want to live under or very near high voltage power lines. They carry strong electromagnetic fields around them as well. It is however possible to shield magnetic fields. Shielding. If someone were to switch off the input signal to a large MEG, the field may not die away instantly, which would result in a field spike as it follows suit to the signals. Then M pulses may arise, which are very destructive to all electronic equipment. These M pulses are so destructive in fact, that some nations have conducted extensive research into their possible application as a weapon. A Faraday cage would form the dike around the lake for the MEG. This is a metal case enclosing the magnetic field plus the MEG completely. With the exception of strong EMP effects, it will keep a semi-steady field contained so that no outside negative effects will occur. So in the course of normal operation, the MEG can be shielded quite easily. The worrisome moments occur when switching the MEG on or off. How will the shielding affect the ability of the vector potential field energy to replenish itself as energy leaves the unit? We need to proceed with caution. Concluding, we can say that the MEG is a means to pour energy from a tremendous reservoir with remarkable little effort. The result is almost limitless energy at practically no cost. The only drawback known in the current state of research is that on a large scale nasty, hard to control side effects may rear their ugly heads. Therefore, while the MEG represents a groundbreaking and innovative new technology, it should not be rushed to market without exhaustive testing.